The motivation for this project is to determine the principle of Newton's second law of motion, which gives the relationship between net force, acceleration, and mass. The equation used to quantitatively visualize the application of Newton's second law is the following. A equals F of net over m, where A is acceleration, F of net is the net force, and m is the mass of an object. Our goal is to determine if an object with a greater mass will experience a smaller acceleration and net force than an object with a lighter mass, because unbalanced forces cause objects to accelerate with an acceleration that is directly proportional to the net force and inversely proportional to the mass. The first physics concept used in the hypothesis of this experiment was the principle of Newton's second law of motion, which gives the relationship between the net force, acceleration, and mass of an object. The second physics concept that was utilized in this experiment was the conservation of energy, in which the initial and final potential kinetic velocities are equal. The conservation of energy concept was important to consider when determining the final velocity of the objects, instead of the acceleration force due to the curve rather than flat car track. Also, the velocity versus time graphs will provide the x and y component of the system, which will help calculate and compare the predicted and observed final velocities. For our original prediction, we hypothesized that acceleration, force, and mass would be considered, and that the heavier object would have a greater acceleration and force than the lighter object. Our calculated prediction was a final velocity of 2.4 meters per second. For our observations, we found that the acceleration, force, and mass are not considered when the system consists of a curved ramp, and the calculation of comparison of predicted and observed final velocity should be used to confirm the conservation of energy. Our calculated observation was a final velocity of 2.13 meters per second. For our data, the length of the track was 103 centimeters, the height from track to table was 74 centimeters, and the distance from ground to end of ramp was 72 centimeters. The mass of car number 1 was 45 grams, and the mass of car number 2 was 34 grams. The height at the top and bottom positions respectively was 0.788 meters and 0.492 meters, and the difference in height was 0.296 meters.
Trial 1, 3, 2, 1, go. Trial 2, 3, 2, 1, go. Trial 3, 3, 2, 1, go.
As shown in the graphs, our observed final velocity was 2.13 meters per second, compared to our predicted final velocity 2.4 meters per second. This leaves us with a percent error of 12.7%. In conclusion, this experiment revealed that acceleration, force, and mass are not considered when an object is moving down a curved ramp. Instead, the final velocities of the object must be determined in the context of the conservation of energy, in which the initial and final potential and kinetic energies are equal to each other. Even though our hypothesis assumed that mass had an influence on the acceleration of the objects and the force required to move the object, the formula used to calculate the final velocity excluded the object's mass. In this way, the final velocities takes into account the height difference between the top and bottom positions as well as acceleration due to gravity. The predicted final velocity was the same for both heavy and light toy cars because they fall down the car track at the same height, and the observed final velocity was composed of the horizontal and vertical velocities. In the end, we found that the predicted and observed final velocities had a low percent error of 12.7%, and the conservation of energy was demonstrated through Newton's second law of motion.